Hello everyone, this is a video lecture series in which we are going to discuss about different type of problems which appear in different competitive exams related to physics. Either it might be NET exam, either it might be GATE exam, SET exam, or any type of competitive exam. So I'm not trying to give or explain any type of theoretical concepts, or I won't give any kind of background related to any concept. Straight away I will discuss different problems related to certain topics. So today's lecture will be on linear differential equation, more precisely linear differential equation of first order and first degree. So let's begin. So first type is variable separation method. If we consider m as variable which is function of x only given by f of x, and n as a function of y only given by g of y. So if the problem appears something which looks something like this, f of x dx plus g of y dy equal to 0. So this is this is a very simple type of differential equation. We can simply find the solution by just integrating this f of x and g of y. So we will get a solution as f of x dx integration of g of y dy equal to c, where c is considered to be a constant. So you might have seen this type of problems while you have gone through your postgraduate course, but how do we solve this real-time equations, or how do we solve this type of problem in real time? Because in NET examination or SET examination, they simply don't give the equations, they just plot the questions in the form of words or in the form of statement. So we need to decode such type of statement. So first of all, we will just try to solve the example related to this type of differential equation. So we will consider first differential equation, that is a Schrodinger's time dependent equation, which is given by IH cross dabba psi by dabba t equal to E psi. So we can see over here that this is a problem related to our type, that is variable separation type or variable separation method. So how do we solve this? So we need the reason why I am calling it as a variable separation, because we need to separate out different variables. So how do we separate over here? So it will be something dabba psi by psi, which will be equal to IH cross, or sorry, it will be E by IH cross D or dabba t. So simply integrate this equation, we will find our solution. So which will be log of psi equal to E by IH cross T, or I can write this as plus log of C. So I can rewrite this equation as log of psi by C equal to ET by IH cross. Or I can rewrite that equation as psi equal to C e to the power minus I E T by H cross. We know that I square is equal to minus 1. So just I have multiplied over here I by I on numerator and denominator, so just this equation has been rewritten as minus I e t by h cross. And if we just substitute the limits, then I can write this solution as psi equal to psi naught e to the power minus I e t by h cross. Let us consider another example of similar type, that is Newton's law of cooling. So if we consider a thermodynamical system whose temperature is T, which is kept in a surrounding, and the temperature of the surrounding is something Ts, and we know whenever we keep a thermodynamical system in a surrounding, then its temperature decreases. Then if we try to represent this system in the form of equation, we can rewrite something like this: minus dt by dt, which is proportional to decrease in temperature T minus Ts, where capital T represents the temperature of thermodynamical system which is under consideration, and small t represents the time with which the temperature decreases, and Ts is nothing but a surrounding temperature. So if we substitute the constant of proportionality, then we can rewrite this equation as dt by small dt, which is equal to minus k T minus Ts. Or this equation can be rewritten in our required form, that is, or I am calling it as a variable separation form, as dt by T minus Ts equal to minus k dt. Now we have obtained our regular form, so simply integrate the equation and we will get the solution. So the solution will be something log of T minus Ts equal to minus kt, where the time vary from 0 to t and temperature will vary from T1 to T2. So if we substitute the values of T1 and T2 in above equation, we get the equation something like this: log of T2 minus Ts by T1 minus Ts equal to minus kt. So just remember this equation, because plenty of questions are asked related to these questions. Mostly they ask questions in your gate examination for 2 marks. This type of questions definitely they ask in your gate examination. So let us check one example related to this type. Boiling solution at 100 degrees Celsius is placed on a table where surrounding temperature is 20 degrees Celsius. The solution is cooled to 60 degrees Celsius within 5 minutes. So how long will it take to cool to 30 degrees Celsius? So over here the surrounding temperature is equal to 20 degrees Celsius, and in this problem it requires 5 minutes to cool down from 100 degrees Celsius to 60 degrees Celsius, and we are supposed to determine the time required to cool down to 30 degrees Celsius from 60 degrees Celsius. So as per our formula which we have derived just now, which is given by ln of T2 minus Ts by T1 minus Ts equal to minus kt. So in this equation k is unknown, so we need to determine the k by considering first process, that is conversion of 100 degrees Celsius to 60 degrees Celsius. So the final temperature is considered to be T2 and the initial temperature as T1. So substituting values, T2 will be equal to 60 and T1 will be equal to 100, which will be equal to minus k into 5 minutes. I'm not converting that time into seconds, I'm keeping it as it is. So it will be equal to log of 60 minus 20, which is equal to 40, and 100 minus 20, which is equal to 80, which is equal to minus 5k, or I can rewrite as k equal to 1 by 5 log of 2. So minus minus get cancelled, since over here we get 1 by 2. So we know the property that log of 1 by 2 will be equal to minus log of 2, and this minus minus will get cancelled. So the value of k is equal to 1 upon 5 log of 2. Now we need to determine the time required to convert or to cool down the temperature to 30 degrees Celsius from 60 degrees Celsius. So now we will consider the second system, that is 60 to 30 degrees Celsius. So let's determine that time. So log of T2 minus same formula. But now over here T2 will be equal to 30 and T1 will be equal to 60. And minus 1 by 5 log of 2 into t, where t is unknown. So it will be equal to log of 10 by 60 minus 20, which is equal to 40, which is equal to minus 1 by 5 log of 2, or t by 5 log of 2. Now it will be written as ln of 4, which is equal to minus t by 5 ln of 2. But log of 4 can be written as 2 ln of 2, because 4 is equal to 2 square, so we can rewrite it as 2 log of 2, which is equal to minus t by 5 log of 2, and log of 2 and log of 2 get cancelled. So t, the minus over here will get cancelled. Over here it was log of 1 by 4, so after converting into log of 4, the minus minus will get cancelled over here. I just forgot that thing. So time will be equal to 5 into 2, which is equal to 10 minutes. So 10 minutes are required to cool down the solution from 60 degrees Celsius to 30 degrees Celsius. So it is a very simple formula over here, just log of T2 minus Ts by T1 minus Ts. Such kind of problems will be asked for 2 marks in GATE examination. This is a direct question. So I will provide you one question in the description which is quite similar to this problem. So just go through that problem and try to solve the question, and I will give the solution along with that question. Just first of all try to solve on your own and just cross verify your final answer. I will just provide you the final answer. So one more question they ask you in your exams related to this variable separation method. So they ask you to find the orthogonal trajectories of a given equation. So they provide you some curve, something f of xy equal to some constant c, and they ask you to determine the orthogonal trajectories. So how do we determine the orthogonal trajectory? So there are 3 steps. Simply find the slope of a given curve. So let dy by dx be the slope of a given curve. Then in second step we need to take the negative reciprocal of the given slope. So if dy by dx is I will write as dy by dx given. So the slope for orthogonal trajectory will be dy by dx OTH, which will be equal to minus 1 upon dy by dx of a given curve. And in third step, apply the variable separation method. apply variable separation method and you will get the corresponding required equation, or I can say required orthogonal family. So let us consider an example to clarify this type or this type of question. So you can see the equation over here, x square plus y square equal to c square. This is the equation of a circle. So first of all, what is the first step? To determine the slope. So how do we determine the slope? Just simply take the derivative. So it will be the derivative will be dx 2x dx plus 2y dy, which will be equal to 0 since the derivative of a constant is equal to 0. Now rewrite this equation in terms of dy by dx. So 2x dx will be equal to minus 2y dy. 2 get cancelled, which can be written as this is the dy. So dy by dx of a given curve is equal to minus x by y. So we have completed our first step to determine the slope of a given equation. Now determine the slope of an orthogonal family. So dy by dx of orthogonal family is equal to minus 1 upon dy by dx of a given. So minus x by y, which will be equal to y by x. So dy by dx orthogonal, or I can say the slope of an orthogonal family will be equal is given by dy by dx orthogonal is equal to y by x. Now simply apply the third step, that is to apply the variable separation method. So dy x dy, 1 by y dy will be equal to 1 by x dx, and simply integrate the variables. So we will get log of y equal to log of x plus log of c. So cancelling out the log, or just if we simplify the above equation, we will get y equal to x into c. So this is the equation of orthogonal family, or the orthogonal family of a given curve. So in this way we can determine the orthogonal families by variable separation method. So let us consider another example to find the orthogonal family or orthogonal trajectory of a given equation or given curve. So the next example is xy equal to c. So first step is to determine the slope. So how do we determine the slope? Just take the derivative. So it will be taken as x dy plus y dx equal to c. So rewrite this equation in terms of dy by dx. So dy by dx will be equal to minus y by x. And in second step we need to determine this orthogonal slope. So dy by dx orthogonal will be equal to minus 1 upon slope of a given curve, that is minus y by x. So it will be equal to x upon y. And in third step just apply the variable separation method on this equation, or on the slope of the orthogonal family. So how do we apply this? It will be y dy equal to x dx, and just simply integrate, you will get the trajectory family. So it will be y square by 2 plus which will be equal to x square by 2 plus c. Or if I rewrite this equation, I can write y square by 2 minus x square by 2 equal to c, which is the equation of our hyperbola. So in this way we can determine the orthogonal trajectories of a given curves. Video we have learned the variable separation method, that is if we have provided with the equation that is m dx plus n dy equal to 0, then just if m is a function of x only and n is a function of y only, then simply integrate this equation m dx plus n dy will give us the solution of a given differential equation. And with the help of variable separation method, we have just gone through two types, that is we have studied about the Newton's law of cooling, and we have studied to determine the orthogonal trajectories of given curves. So in Newton's law of cooling, we have derived a formula log of T2 minus Ts by T1 minus Ts, which is equal to minus Kt, where T is the time required for the cooling down, where T2 is the final temperature, Ts is the surrounding temperature, T1 is the initial temperature. And in the last method, that is in the last type, that is last type of problem, that is to determine the orthogonal trajectories, in this we are provided with some equation f of xy equal to c. So we need to determine the slope of that equation, find the slope, then just take a negative reciprocal, then just apply variable separation method, and you will get the corresponding orthogonal trajectory, or orthogonal curve, or orthogonal family of curves, I will say orthogonal family of curves, or of a given curve. So that's it for today. Thank you.